Hello, everyone. Welcome. So today's topic is going to be about secant and tangent lines. So we'll explain basically what they are, how they work, and how to use them. So our goal is to be able to understand both the graph and be able to graph both secant and tangent lines. We'll explain those, understand how they're related to each other, and also introduce what's called the average rate of change between 2 points in the graph. So first, let's talk about a secant line. So here the definition on the left is a secant line to a graph is a line that passes through 2 points on the graph. Remember, we were talking about, of course, when we say the word line, of course, we're talking about a straight line, and the graph could be any kind of curve. For a secant line that goes through 2 points, let's call our x is a and b. In this case, kind of generally, let's call our y for a, its y is f of a. We plug it in over some function f, and for b, its y is f of b. Then the slope of the secant line is just the same as the slope of any line. Okay, basically the change in y would change in x. So basically the same as y2 minus y1 over x2 minus x1. That's a formula you're familiar with. So let's come over here to the right and actually talk about this a bit more. So secant line. So imagine any curve, say of a curve like this. Okay, there's some graph. Let's call this our f of x. Our function. Now, if I pick any points, let's say I pick these 2 points right here. Okay. So this point right here, this is our point A, and its y value is f of a. And this point is b, and its y value is f. I plug it in, the function, get f of b. And the secant line is the straight line that goes through these 2 points. I can pick any 2 points on the graph, and if I connect those 2 points through a line, that's called a secant line. Okay. Now, and once again, the slope of that line is the same as the slope of any line. Okay, this is still just a line. Now, let's introduce the idea of a tangent line. Okay, a tangent line, as it says over here on the left, is a line that only touches 1 point in the graph. It goes through 1 point. So let's graph that over here. And actually, we'll just use basically the same function. I'm just going to call this our y equals f of x. Okay, so let's say the graph goes through this point right here. So it only touches that 1 point. Okay, so a line that just touches, sorry, it should be a straight line. Let me try that again. Well, I'm having a hard time drawing a straight line. Let me try it one more time. You get the idea, though. It should be a straight line that goes through this point. All right, let's make this simpler. Basically, it only touches that point, only touches that graph in 1 point. Okay, and we could let's call that point here just call that point our B point this time, B, and plug in B, f of B. Okay. Now, what's interesting, as I'll be here in a minute, is that if we think about this tangent line, and let's say maybe this, of course, this different point B than you see here, but if we make A closer and closer to B, then if we can essentially put A as close as possible to B, then we can essentially make the secant line basically a tangent line. We'll talk about that in just a moment. Okay. But first, let's practice with it. So first, I want to take a look at a website called Desmos. And some of you are probably familiar with Desmos. It's a really good site. Helps you to graph, and you can also do calculations on Desmos. So let's take a look at that. Now let's take a look at a function we'll be familiar with. So here's Desmos, desmos.com. So click on Graphing Calculator. Now, let's do a graph we're all familiar with. Let's do y equals x squared. Okay. Now, let's say I want to do a graph, we can also plot individual points. Let's say I want to do a secant line between 0, 0, the origin, and the point 2, 4, which is also on the graph. Okay. Now, if you remember your regular college algebra, you can actually graph that. You can find the graph of that line. That line turns out to be y equals 2x for a secant line. So I graph y equals 2x. So you find the slope between those 2 points. You find the equation y equals 2x. That actually then is our secant line. It's the line that goes through those 2 points. Okay. And once again, I can if I pick any 2 different points on any function like this, y equals x squared or anything, and I draw a line between those 2 points, that's a secant line. Okay. Now we can also do a tangent line to either point. Let's do the point 4, 2, 4. So let me, another nice feature of Desmos, I can turn these graphs on and off by clicking on this. So let's turn this off just a moment. Now, let's say we'll do a tangent line to this point right here. So once again, if you, and those of you learning calculus, you learn how to actually calculate the slope of that line using calculus. But basically, I can do a tangent line, and it turns out that line is going to be y equals 4x minus 4. And if you see, that line touches that graph at only 1 point. Okay, we can zoom out a bit, zoom out once and see, yeah, it's only touching it right there. So that is a tangent line to that point at 2, 4. Okay. So once again, so this first one, let's go back and put our secant line on there again. So the secant line between these 2 points is 2, 4. Between 0, 0, and 2, 4 is this line. That actually is a slope of 2. Now, and then our tangent line, it touches the point 2, 4 in only one spot. Doesn't touch it, y equals x squared anywhere else, as this equation. And once again, how to find these equations is something that we're not talking about in this particular lesson, but if you remember your college algebra or see other videos in college algebra, you'll learn how to do that. And also this is important in calculus as well, especially with the tangent line. Now, another thing I'll mention before we move on from this graph is you imagine I get closer, if I pick my x value here instead of 0, if I pick it closer and closer to 2, then this secant line will get closer and closer to a tangent line. So let's go back and consider that idea on our paper. So for a secant line, is A, we'll call this approaches B, this little arrow means A gets closer to B, then the secant line gets closer to, I'll say closer, basically closer to being a tangent line. Okay, let's draw another, maybe another function, maybe like a power function we see here. Okay, I was going to have a little trouble drawing nice curves today with my picture. All right, so let's say this is our point. Let's call this, say, our point f of b. So this is b. If we plug in, this is f of b. Okay, now imagine I start a point right here. Okay, make this secant line. Right. Okay, now let's say I pick another point right here, do another secant line, and another point right here, and do another secant line. In fact, let me actually change, well, I have to draw it a different color. Do another secant line right here, and you get the idea. So as my A, let's call this A1, A2, A3, and so forth. So as my A's get closer and closer to B, this actually is closer and closer to a tangent line. Okay, and that's what this says right over here. So it says if you create a secant line with the graph and move A as close as possible to B, the slope of the tangent line approaches the slope of the tangent line. So basically, a secant line can essentially become a tangent line, and the slope approaches the slope of your secant line approaches the slope of that tangent line. Okay. Now this right here is something that those of you learning calculus will learn. This LAM means limit. So what that means is A gets as close as possible to B. It doesn't have to ever actually equal B. It just has to get as close as possible to B. And once that happens, then you actually have a tangent line. Okay, let's discuss one more idea in this video. Let's talk about the average rate of change. Okay, so the average rate of change. So I apologize. I haven't actually used my writing pad in a little while. I'm a little rusty on it. Okay, so the average rate of change of a function y of x between 2 points, one can call them a and f of a and b and f of b, is just a secant line between those 2 points. But basically what it tells you is an average rate of change of some function between 2 points. Okay, so basically I could draw the graph. I could simply say, go back to my secant graph here, and simply say that this secant line here, the slope of that line represents the average rate of change. Yeah, it's the slope of that secant line. So the slope of the secant line represents the average rate of change between points A and B. Now, once again, it only takes into account, this says it only takes into account points A and B. Nothing happens in between. So it's a useful idea, but it doesn't tell you everything, okay? Because there can be a lot of change in between A and B. For example, essentially you have a maximum, kind of a local maximum value here. We climb this hill and go back down. But so if you just look at these 2 points, from A to B, there isn't much change, but actually there's quite a bit of change in between. So it's a useful idea, but it doesn't tell you everything. Let's do one quick example of this average rate of change. So let's draw a graph. Actually, I don't really need these. Let's say this is an example of a stock price. Over time. Okay. So let's say we have some other function and use a function like we saw before, maybe something like our f of x earlier. Okay. Now, let's say on this point right here, and let's call this day 1, and let's say our stock price is, I'm gonna make up something, say it's $50. So $50 per share. Okay. Now, let's come over here, and maybe this is day number 10. And let's say the stock price is now, it's a little bit less, let's say it's 45. I'm just making up these numbers, but you get the idea. Okay. Now I can find the average rate of change. So think about the slope of this line that goes through both those 2 points. I can find the average rate of change. It's just the slope of that line. Okay. So just change in y over change in x. So it's going to be 50. And let's go and think about our units too. $50 minus $45. Okay. Over 10 minus 1. I think there's the same rules of slope. If I start with this, oops, in fact, I got that backwards. Sorry. It doesn't matter, but I actually did that backwards. So if I start with this y value, I have to start with the same x value below. So 1 minus 10. Okay. And so that's going to be 5 over negative 9. And let's actually calculate that. So use your calculator. And it's not going to be that evenly, but that's okay. So since dollars, we'll round off to the nearest cent. And that turns out to be, remember our values here are dollars per day, capital D. And that's going to be, if we round it off, it's going to be approximately, that's going to be negative, because it is, or we have a negative slope. Oops, let me put that the other way. A negative point, looks like 56 cents per day. Okay. So what that tells you, once again, is your average rate of change. So just taking those 2 points into account, the average rate of change between day 1 and day 10 was about 56 cents per day. Okay. Now, but as you see, a lot happened in between there. Okay. price got higher, then went lower, then it started to come back up. So this is a useful information to take into account. And we just look at those 2 days and say, okay, on average, and basically the stock price is going down about half a dollar a day, a little more than that. But it doesn't say everything. It doesn't say what's happening in between. But it can be useful measure and understanding information. Okay, so let's quickly review just a moment. So what we learned today, or basically understood the definition of secant lines and tangent lines, kind of how to graph them. Basically, you can make sure you know how from algebra how to graph lines. It works the same way. Find the slope of a secant line and the slope of a tangent line, or just the slopes of lines. And as your points A and B act for x values, if A gets as close as possible to B, then basically approximates the tangent line. It becomes not just the average rate of change, but actually one more thing is a tangent line, the slope of the tangent line tells you the instantaneous rate of change at a certain point. Thank you. Have a good day.